Pascal's triangle, because we are Eurocentric and name thing after dead white guys, although it's probably developed by other civilizations before Pascal got to it, but he got his name stuck on it. It's named after Blaise Pascal, who's a French mathematician from a lot of years ago. Fill in the blanks in the diagram below by stating the number of different routes the ball can take to reach that point. So how many ways can it get here? One way, right? It's got to come.
Oh, it's like back here.
Yeah. How many ways can it get here? One. Here. One. Here. Here. Okay. And we've got two ways, right? Because it can come from the left or the right. And here. 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 Here, middle, here, outer. So how many different routes can the ball take to reach any of the slots? And we would add this up, 1, 5, 11, 15, 16 routes. Okay, so there are 16 different routes. The above pattern numbers can be seen as the first few rows of what's called Pascal's triangle. Pascal's triangle is very similar to the pathway. Remember we did the pathways and it was the same deal, right? It's like, well, how can you get here? Well, I can come from any of the three paths that came to this point or any of the three paths that came to this point. And so that gives me 6 different paths to get to that point. So here's Pascal's triangle. Now, why it says Alberta, I didn't make them do that, but it's as a result. I said, sometimes, and if you go on to study further math, sometimes Pascal's triangle, the top row is called row 0. Okay, and then row 1, row 2, row 3. But for Alberta education, for your purposes, top row is row 1. Okay. So anytime we refer to or do anything with Pascal's triangle, it's row 1, row 2, row 3, row 4, and so on. All right, so row 1, sum of the terms. So if we add up, what's the sum of the terms? 1. Good. Took some work to get there. Okay, just give me half. Row 2, 1 and 1. 2. Row 3, 1 plus 2 plus 1. 1 plus 3 plus 3 plus 1. 1 plus 4 plus, we just did that one, right? That's 16. You noticing a pattern here? So what's the next one? Probably 32, right? Okay, so 10, 20, 32. Okay, so that is actually true. So we have 32. Notice how row 1 has 1 term. Row 2 has 2 terms. Row 3 has 3 terms, right? So this is how we're going to look at this, right? So the first row has 1 term, second row 2 terms, third row 3 terms, etc. Also, notice how any given term in Pascal's triangle can be found from the sum of the 2 terms in the row above it. For example, the third term in row 5, so here's row 5, and this is 1, 2, this is the third term, is the sum of the second and the third terms in row 4. This is just like the pathway problem shown at the top of the page, right? So I drew arrows in as if it's the arrows that are down below. Complete the next 2 rows in Pascal's triangle using this pattern. Okay, so we've got row 5 and row 6. So this is row 5, and this is row 6. So you need row 7 and row 8. Okay, so I'm going to pause. So row 7, we see the outside of each row is always just 1, and if you imagine you're adding 2 numbers, you don't have anything here to add, so there's nothing that goes with this, so it's just the 1. Okay, then we start adding. 1 and 5 is 6, 15, 20, 15, 6, and 1. And in row 8, the 1, 1 and 6, 7, 21, 35, 35 again. So you notice some rows have a repeating number. 1, 3, 3, 1, 1, 5, 10, 10, 1, 7, 21, 35, 35, and some rows don't have a repeating number. Right? They just have a middle. It depends on how many terms are in the row. Okay, if there's an odd number of terms in the row, then it's going to have a middle that will be unique. If there's an even number of terms in the row, and how many terms in row 8? How many terms in row 1? 1. Row 2? 2. Row 8? 8. Okay? So there is no middle, right? Or if there's a middle, it's like in between two terms. So there's two terms in the middle. So how many terms are there in row 3? Row 6? 6. Row 300? 300. Okay, so if we're referring to a row, we know how many terms are in the row, right? As many terms as whatever number of row you're referring to.
Are we going to do the sum too?
Yeah. Here. Determine the sum of the terms in each of the first 6 rows of Pascal's triangle and write your answers in the column besides Pascal's triangle. First write the sum as a number, then as a power of 2. Okay, so let's go back. So we could see as we were getting down here, and we knew this was 16, then we're thinking, hey, you know, you're just doubling, you know, there's powers of 2. So this is 2 to the power of 2 to the power of 2, 2, this would be 2. Now, how's this number relate to the row number? 1 less, right? 1 less, because I mean, row 1 you can't go to like, it's 2 less, right? So row 1 is 2 to the negative, no, okay, it's not that, right? It's row 1. So row 1 has one number. The number is 1. The sum is 1. That's 2 to the 0. So if you're thinking about, well, how does the row number relate to if I want to add up the terms in the row, then it's 2 to the n minus 1, where n is the row. Okay, so that's what we're going to write here. First is not. How does the exponent of the power of 2 compare to the row number? So what's the magic word? Compared to the row number, it is 1 less. So 1 less than the row number. So the exponent on 2 is 1 less than the row number. The exponent on the 2 is 1 less than the row number. Now, if you're not going to end up kind of memorizing this stuff, you're going to at least have to be able to come up with a way to figure it out, right? And that might mean on a test or something, you just sort of generate the first 3 or 4 rows, and then just sort of say, okay, this is row 1, and it's got 1 term, and its sum is 2 to the 0. This is row 2, has 2 terms, it's 2 to the 1, and so on. Okay, so if we start talking about the 23rd row, you've got something to refer to, right? And it's not like some half-memorized thing of, what is 2 to the power of 1? Right, because you can generate that for yourself, right? If you just generate the first 3 or 4 rows for yourself, and I ask about row 23, you're like, okay, yeah, I can see the pattern. I'll be able to answer the question, right? So the sum of the terms in the nth row is what? 2 to the n minus 1. Okay? Now, if you don't know that, right, and I don't think that's necessarily something worth memorizing, again, just generate like the first 4 rows, write out the sums, write out the sum as a power of 2, and just, okay, row 4 is 2 cubed. Now, if you've got that, then what are the sums in the 10th row? 2 to the 9th, right? So you'll go, it's 2 to the 10 minus 1, which is 2 to the 9th, which is 512. Okay, you can pull your calculator out for that, or especially for the next one, because what's the sum of the terms in the 23rd row? So it's 2 to the 23 minus 1, which is 2 to the 22, which you need a calculator for, or I think I might have answers written down. So 4,194,304, right? So depending on your level of comfort or whatever, you might want to memorize that it's, you know, I just think there's too much there, and that if I just sort of write out the first 4 rows for myself, that I can see all the patterns that are going on in there. Given a portion of Pascal's triangle, it's easy to generate the next row, right? We had the first, 6 rows, we generated the 7th and 8th, or for the first 5, we generated the next 2. What if you wanted to find a term in the 57th row? Either you carry it down, get row 56 done, and now you can generate row 57. right? That's called it's a recursive definition. So recursive definition just means in terms of what came before, which means you need what came before. If I want to do the 57th row, I need the 56th row. But we're not going to do that, right? It's tedious and time consuming. But we're going to look for a pattern to see how can we find any value in any given row of Pascal's triangle without knowing the row before it. To do that, we're going to write Pascal's triangle, but we're going to use combinations. So row 1, instead of saying 1, we're saying 0, choose 0. Now 0, choose 0 has to be 1, right? There's only one way to choose nothing from a set of nothing, which is nothing. You don't take anything. Row 2 is 1, choose 0. Only one way to choose no items. Just don't choose. And 1, choose 1. Again, only one way, right? That's a 1, 1, 1. We know this has to be 1, 2, 1. Right? There's only one way to choose none or all of the objects, right? So the outside of Pascal's triangle is like 4, choose 0. How do I choose 0 items from a set of any number of them? Only one way, right? Just don't choose any of them. How do I choose all of the items from any set of numbers? Choose all of them is only one way, right? All of them, boom, I got them all. There's only one way I can do that. I decline to choose any. There's only one way I can do that. And then we start to move into the middle of here, right? So row 4, which starts out as 3, choose 0. So again, you'll notice how is the row number related to, this number here. And if you think about it, right, if we're choosing, so we're in row 3. In row 3, we know there are 3 terms, right? We know there are n terms in row n. Okay? That's one thing you can learn, or very easily get, just by writing out the first 4 rows again, right? So in row 3, there's 3. So if I were thinking, oh, well, it's row 3, there's 3 terms, so I need to go like 3, choose 0, 3. No, wait a second. If I do that, I've got 3, choose 0, 3, choose 1, 3, choose 2, and 3, choose 3, right? There's 4 ways of choosing from a set of 3 objects, because one of those ways is choosing none of them. So because of this, if I'm in row 3, I know there's 3 terms, then I know it has to start 2, choose 0, right? Because if I'm choosing from 2 objects, I can do that 0 ways, 1 way, or 2 ways, right? Choose both of them, none of them, 1 of them, or 2 of them. These numbers are just generated, right? 0, choose 0, etc. 3, choose 1, 3, choose 2, 3, choose 0, 3, choose 1, 3, choose 2, 3, choose 3. Write the next row using combination notation. Okay, so we're just going to move down. So this is row 5. This is row 6. So I want row 7. Row 7 has 7 terms in it, and I just have to realize, well, it can't start with 7, choose 0, because if 0 is part of that, to get 7 terms, it's going to be 6, choose 0. And then 6, choose, what do I try? 6, choose 0. 6, choose 1. 6, choose 2. 6, choose 3. 6, choose 4, 6, choose 5, and 6, choose 6. And make sure you're writing it in the appropriate places, right? Like nothing goes directly underneath something else. It's always these 2 guys here are going to add together to give me this. If I had the actual numbers, right? So if I was generating this from scratch, I would need these numbers. If I'm generating this here, and I say, hey, I want the 4th term in the 7th row, well, that's the first term, right? It starts with 0. 2nd, 3rd, 4th. Then I know I got to go 6, choose 3. That we can work out. Right, we got calculators and everything. So every term in Pascal's triangle can be expressed as n choose r. Starts from n choose 0, goes up to n choose n. For each row of Pascal's triangle, the value of n is blank than the row number. 1 less. Okay, so the value of n is 1 less than the row number. Also, the r value for each term is then the term number. So the first term in row 7 is 6, choose 0. The first term is 6, choose 0. The second term is 6, choose 1. The last term in the 7th row is 6, choose 6. So how does that compare to the... So the value for each term, so term 1, the r value is 0. Term 2, so it's 1 less than the term number. Also 1 less. For example, if you wanted to find a term in the 27th row, so the 27th row, what's n? 26. If you wanted the 7th term in any row, the value of r would be 6. Okay. So just remember as you go along a row, right? In combinatorics notation, it's always starting with n choose 0, n choose 1, n choose 2, and so on, all the way up to n choose n. If the pattern is continued, express the terms of the 9th row in Pascal's triangle as combinations and then as numbers. Okay, so 9th row, how many terms in the 9th row? 9 terms. What does it start with? What number? 8. So 8 choose 0, 8 choose 1. Where the parenthesis notation actually comes in a little handier, right? So how many terms is that? So if you actually count them, the first term is term 0, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, right? It's always one more than the number that you're starting with. Because you're going from 8 choose 0. So, I mean, 8 choose 8. Obviously, there's 8 of those, right? 8 choose 1, 2, 3, 4. But then we also say, oh, wait, but you could choose none of them. So that's 8 choose 0. So that's 9. As numbers, so 8 choose 0 is 1. 8 choose 1 is 8. 8 choose 2 is 8 times 7, 14. No, 28. 8 choose 3, 56. 8 choose 4, I'm not where I can, I know 8 choose 5. 8 choose 5 is the same as 8 choose 3, right? It's like if I choose you 3 people to go somewhere, it's like choosing you 5 people to stay. So I can do this. That's 28, 8, 1. And I need 8 choose 4. So 8 times 7 times 6 times 5. For 8. I think it's 70, but somebody should check that. Verify my term. What's 8 choose 4? 70? Be impressed. I wasn't looking at the key. Yeah. Look at the beard. How could you think otherwise? Yeah. Yeah, or Santa Claus. Okay. So if I said, what's the 5th term in the 9th row, you have to say the 9th row starts with 8 choose 0. 8 choose 0 is the first term. I want the 5th term. That's going to be 8 choose 4, right? So it would be 70. And I think they probably asked that on the next page. The last example demonstrates how to state any given row without having to generate all the rows. The second term in the 23rd row. So the 23rd row starts with something choose 0. What? 22, right? So the second term is going to be 22 choose 1, which is, we don't need a calculator, 22. Right? If you have 22 items, you're only choosing one of them, that's 22 ways, right? The 11th term in the 17th row, we will need a calculator. So the 17th row starts with what? 16. The 11th term is choose 10, right? Because we got to remember, it starts with, 17th row starts with 16 choose 0. So the 11th term is one less at 16 choose 10, which is 8,000. Sorry, yours aren't working. 8008. How? It's a palindrome. Which, funny enough, was the name of the last episode of Fargo, but I don't recall seeing any palindromes. The 47th term in the 50th row. So what does the 50th row start with? 49. Choose. I want the 47th term. 46. Okay. 18,424. Save you having to reach for your calculator. What are the first three terms in the 12th row? Yeah, so we're going to start off by saying 11, choose 0. I'm going to default to bracket notation now because it's just a bit easier, right? So you got to start by saying, well, it's 11, choose 0, 11, choose 1, 11, choose 2, and then you could list those. So 11, choose 0 is 1, right? I mean, the first term in any row is always a 1. 11, choose 1 is 11, and 11, choose 2 is 55. Okay, so 1, 11, 55. Says verifying the. Yep. What are the last three terms in the 18th row? Yeah, I'm going to write them backwards. So I know it ends with 17, choose 17, and then 17, choose 16, 17, choose 15. Okay, and those would be, well, I know it's a 1, and I know before the 1 there's a 17, and then the other one's going to be 80 and 50, 136 maybe? What's 17, choose 15? 136. Because when I did this stuff 150 years, no. I could actually let you know how many, no, I'd figure out how many years ago, but it would be depressing. When I did this stuff in high school, we didn't have calculators, so you had to be able to do. So I look at 17, choose 50, and I say it's 17 times 16 over 2, right? Because it's 17 factorial over 17 minus 15 factorial, 15 factorial. So I just go, okay, it's 17 times 16, right? Eliminate anything below that. 17 minus 15 is 2 factorial, which is 2. So I just go, it's 17 times 8, and then I just do 17 times 8, right? 10 times 8 is 80, 7 times 8 is 56, 80 and 56 is 136. What would be, which I'm not doing in my head, what would be the middle term in the 25th row? 25th row has how many terms? 25 terms. What's the middle? If I have a set of 25 objects, the middle one is which one? The 13th. How does the 25th row start? 24, choose 0. So it's 24, choose, and I want the 13th term, which will be 24, choose 12. I cannot do, I could do it on paper. I cannot do it in my head. I would not do it on paper. Yeah. Okay, why they made those calculators, right? What would be the middle two terms in the 38? So the 38th row has how many terms? 38. An even number of objects, like 10, does not have a middle term, right? You need an odd number. If I have 5 things, there's a middle, right? The third is in the middle. So 38th row has 38 terms. Where's the middle? 19th and 20th terms, right? Be the two terms that are in the middle. 19th and 20th because they'll have 18 either side of them, right? There'll be 18 terms below term 19, and there'll be 18 terms from 21 up to 38 inclusive. Okay, the 38th row starts out how? So we've got 37, choose. Now we want the middle term, which is the 19th. So 37, choose 18, or 37, choose 19. We know those are the same, right? Because 18 and 19 add up to 37. If these two numbers add up to this, then those terms are the same, right? Because choosing 18 people to go somewhere is like choosing 19 people to stay, or vice versa. Okay, what's either 37, choose 18, or 37, choose 19? Too big. Yeah, okay. Is it? Like, I don't have a number written down. Oh, right, so it does, because it's too big. Why didn't it say that for that one? 24, choose 12 wasn't exactly worth the... For question 2, we discussed how any given term is the sum of the terms above it in the previous row. Using combinations in diagram number 3, we see that the third term in row 6, that is 5, choose 2, is equal to, let's find diagram number 3. the third term in row 6, so 1, 2, 3. So 5 choose 2 is the sum of 4 choose 1 and 4 choose 2. We look at 5 choose 4, it's 4 choose 3 and 4 choose 4. Verify this statement numerically. Okay, so 5 choose 2 is equal to 4 choose 1 plus 4 choose 2. So all we need to do is just actually work this out and see if we get a true statement. Right? So 5 choose 2 is 10, 4 choose 1 is 4, and 4 choose 2 is 6, and 10 is equal to 10. So that's true. Now we always used to do this. Why is that the case? Why is 5 choose 2 the same as 4 choose 1 and 4 choose? The same as the sum of. So I don't know if this comes up later, but I have an explanation for you. See if it makes sense. So let's say there's 5 people, and I want to choose 2 of them. Okay. So what I'm going to do is say, okay, so here's a group of 5 people. I'm going to choose 2 of you. Well, we're going to look at it this way. Either I choose Brad, so Brad's going to be part of it. Right? Because Brad's bad. So I choose Brad, then how many people are left? And how many of them do I need? So 4 choose 1, right? So there's 6 ways of choosing, right? Or, sorry, 4 choose 1. There's 4 ways. If I choose Brad, there's 4 ways of choosing the other person. Or I don't choose Brad. If I don't choose Brad, how many people do I have left to choose from? And how many of them do I need? So 5 choose 2 can be thought of as, hey, I'm going to choose a particular person out of that group of 5. And then 4 choose 1. Or I don't choose them, or, which is plus, I don't choose that person, then there's 4 choose 2. So 5 choose 2, picking 2 people from a group of 5 is like thinking, okay, I chose you, and then from these 4 I choose 1, or I don't chose you, or plus, in this case I choose 2 people from a group of 4. Okay, make sense? And you can do that with any of the, so 6 choose 4, again, leave 1 person out, right? There's six people I'm choosing 4. Okay, I choose a specific person. From the remaining 5, I choose 3, or, so plus, don't choose that specific person, and from the remaining 5, I choose all the people I need. Okay? So that's why you can think, that's how that works, right? That's how that 5 choose. So in general, then, NCR is what?
N minus 1 choose 1.
So N minus 1 choose, now how is this related to this? R minus 1, right? So in other words, from that group of N people, I'm already going to choose the 1 person, which means that now I have 1 fewer person to choose from, but I need 1 fewer person. Or from that group of fewer people, I'm not choosing the person, and then I need all of my choices to come from that smaller group, right? So I choose the 1 person, so I've got 1 fewer to choose from and 1 fewer to choose, or I don't choose the 1 person, and I still have 1 fewer to choose from, but I need everybody. Let's revisit the sums of the terms in each row. Earlier we seen that. That's actually still there, right? I thought somebody might have changed that. I had to laugh. So earlier we saw that it's not English. That the sum of the numbers in the nth row of Pascal's triangle was 2 to the n minus 1. The power on the 2 is 1 less than the row number. Write the sums of the rows again in the far column as a power of 2. Okay, so row 1, 2 to the 0. Row 2, 2 to the 1. Row 3. Okay, so how does that number match up with this number here? It's the same, right? It's 1 less, right? Because we've got to remember, if we're in the 4th row, how many terms do we have? 4th row has 4 terms. Does it start with 4, 2, 0? That's where I always go. Well, okay, then 4, 2, 0, 1, 2, 4. Oh, wait, that's 5 terms, right? So, okay, now I've got to back up 1, right? It's 3, choose 0, 3, choose 1. Okay. That's how I kind of remember these. Or just sort of generate this if you get a bunch of Pascal's triangles question. How does the exponent on the 2 compare to the n value when the triangle is written in the combination notation? It's the same, right? So when you're writing a combination notation, then you say it's 2 to the n when the value is. So 7 choose 0, 7 choose 1, blah, blah, blah. Those terms form a row. What row is this? Okay, so it's got 8 terms. You always count them up, right? Or just say if it's 7, then there's the 7. Oh, but then there's choosing none, right, which is 8. So that's the 8th row. What's the sum of the terms? 2 to the 7th. The 128. What would be the sum of the following terms in this one? 10 choose 0, did it up to 10 choose 10? No. It's the same as the... Which row is this? The 11th row. The 11th row has the sum of what? 2 to the n minus 1, right? Again, just go back to row 1. Row 1 has one term. It's got to be 2 to the 0, right? Row 1 has one term, which is a 1. That has to be 2 to the 0. So it's 2 to the 10th, which is 1,024, and it's the 11th row, right? It has 11 terms. It's the 11th row. What would be the sum of the following? Now, do we have all of these terms? What are we missing? 9 choose 9. So what's the sum going to be? Be 2 to the 9th minus 9 choose 9, right? Because we're not adding that on. 2 to the 9th is 512. What's 9 choose 9? Okay. How many ways can I choose 9 objects from a set of 9? There's only one way. Just choose them all, right? So 512 minus 1. Okay, what are we looking at doing here? So it's 2 to the what? 2 to the 6th. And which term are we missing?
6 choose 4.
6 choose 4. So you're ready to say, look, I could work out each of those, right? 6 choose 0. I could punch that in my calculator that way. 6 choose 0 plus 6 choose 1. But that'd take forever, right? Say, oh, I can just do 2 to the 6th. Okay, so that's 64, right? Minus 6 choose 4, which we know is 15, right? And what's that? 49. Okay. Have you seen this notation before?
I thought we were going to.
Oh, okay. Good. In grade 10? I haven't seen grade 10 in a while, so I never remember when we've seen it. So that's called summation notation, sigma notation, right? That's a capital Greek letter sigma. You might see it in Excel, where it does the same thing. In Excel, it's like add up, right? And so that's what sigma stands for. Capital sigma stands for us, which is add everything up. Okay, well, how do you add everything up? Well, you start with, okay, so this is 14 choose R, and R starts at 0. And then you go 14 choose, and now we increment R, right? So we just add 1. Plus 14 choose 2, plus, and where does it end? 14 choose, it ends with the 14 there, right? So we have 14 choose 0 plus 14 choose 1 plus 14 choose 2 plus 14 choose 14. How many terms are there? 15. Which row of the triangle is it? 15th row. What's the sum? 2 to the 14, right? That just comes from here, right? So that's 2 to the 14. 24, 2048, 16,384. I can only go like one higher than that. Well, maybe 2. The sum, where n starts at 2, is then incremented by 1 each time until it reaches 21. So this is 21 choose 2 minus 1, plus 21 choose 3 minus 1, plus 21 choose 4 minus 1, plus dot dot dot, plus 21 choose 21 minus 1. Okay. Now, I don't know that I would write this necessarily. I might just skip down to what I'm going to write next. So it's 21, whoops, big letter. 21 choose 1, plus 21 choose 2, plus dot dot dot, plus 21 choose 20. Okay. So somehow you come up with this. Okay. If you go there directly, that's fine, right? Like it's not a big deal to just say, okay, it's 21, 2 minus 1 is 1, 21 choose 1, n is now 3, 21 choose 2, n is now 4, 21 choose 3, and so on. N gets to 21, 21 choose 20. Okay, what are we missing? We're missing 21 choose 21 and 21 choose 0, right? So what's the sum going to be? So 2 to the 21 minus 2, right? Everybody know where those 2 came from? Right? One of them is 21 choose 0, and the other one is 21 choose 21. And, yeah, calculator.
2,097,150.
2,097,150. Yeah. I could have done it on paper, but why? Okay, hang on, leave that up there for a second. Okay, so good summation notation. It's just a shorthand, right? That's all. It's just a shorthand. So, this is just the way of saying, hey, add everything up in the 15th row of Pascal's triangle. The 15th row I know starts with 14 choose, because if it starts with 14 choose 0, then there's another 14. That's 15 terms, and the 15th row has 15 terms, and its sum is 2 to the 1 less than the row number, or if it's in this notation, it's just 2 to the whatever the leading n value is. Sum of the numbers in the 5th row is 4 choose 0 plus 4 choose 0, which is 2 to the 4th, which is 16, right? Which gives us, now, we got to think about, all right, so, like, what is all this anyways, right? When we did the 4th row, 4 choose 0, 4 choose 1, that goes right back to this first, right? There's 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4. 16 ways, right? That's the number of paths that the ball can take to get to the bottom of this particular game. Are we going here? Yeah. So it gives us all the different ways of choosing 0 to 4 items from a set of, from a set of 4 items. Use the fundamental counting principle to explain why the sum of these numbers is 2 to the 4th. Okay. So we want to use the fundamental counting principle, which means we're going to put down some blanks, right? So we've got the first item, second item, third item, fourth item. So we talk about item number 1. How many ways are there of choosing item number 1? So I say, so here's item number 1, and I can either choose it or not choose it. So there's 2 ways, right? How about item number 2? Choose it or don't choose it. Item number 3, choose it or don't choose it. So what goes in here? 2. I choose item 1 or I don't, right? It's 2 possibilities. I choose item 2 or I don't. I choose item 3 or I don't. I choose item 4 or I don't. That's 2 to the power of 4, or 16, right? Which is anywhere from I have chosen no items to I have chosen all items, right? And there are 16 ways that that can happen, right? If I choose only one item, that happens 4 ways, right? I choose either the first, or the second, or the third, or the fourth, right? That's the 4 choose 1. If you're choosing one item, there's 4 ways you can do it. If you're choosing no items, there's only one way you can do that. Don't choose, don't choose, don't choose, don't choose, don't choose. If I'm choosing one item, it's like choose this, don't choose that. So 1 times 1 times 1, right? Choose it one way, don't choose, don't choose, don't choose. Or don't choose it one way, choose it one way, don't choose, don't choose. Or don't choose it, don't choose it, choose it, don't choose it. Or, right? That's just 4 ways. If I'm choosing 2, it's either the first and the second, or the first and the third, or the first and the fourth, or the second and the third, or the second and the fourth, or the third and the fourth, right? 6 ways, right? Say it one more time. So choose the first and the second, or the first and the third, or the first and the fourth, or the second and the third, or the second and the fourth, or the third and the fourth. Because we don't care about order, right? It doesn't matter what order we choose things in. 6 ways. Recap. Some of the terms in the 9th row would be 2 to the 8th, which is, yeah. The sum of the terms in the row starting with 19 choose 0 would be 2 to the 19. Okay? That's the recap. That's the nightcap.